Hi, everybody. We're doing part 3 today of section 3.2.8, curve sketching. And again, it's just I want to do a few more examples and go through all the procedures. So let's I just got to switch cameras here. And now I'm looking at my document camera. That's me waving to everybody. And let's start. So we have a function y equals x squared minus 2x plus 4 over x minus 2, and want to sketch the curve. So the first thing the first thing we look for is the domain and range. Well, the domain is just all real numbers, provided that x does not equal 2. So the domain is basically all real numbers except for x equals 2. The range is actually a little trickier to figure out just with algebra. It's going to be easier to get the range after we do some of the calculus. So again, I'm going to hold off on the range, and we'll get back to that. Just like I did on a previous problem, I'm going to hold off on the range. It'll be easier to come back and fill it in later. Let me just fix this. Okay. Here we go. The next thing I want is the x and y intercepts, and the intercepts are, well, the again, if I let x equal 0, if I let x equal 0, I get y equals 0 minus 0 plus 4 over 0 minus 2, which just equals negative 2. So the y-intercept is negative 2, or you could say it's the point 0 comma negative 2. Now, as far as the x-intercept, now you see this function y equals 0 if the top is equal to 0. So I just have to solve the quadratic. In order to find the x-intercept, I just have to solve the quadratic x squared minus 2x plus 4, set that equal to 0. And this cannot be factored, so I'm going to need the quadratic formula. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac. And if you notice, we have this is going to be an imaginary number. This is going to be 2 plus or minus 2 rad 3 I. And when the zeros of this equation are imaginary, that means there's no real number that makes it equal to 0, which means there's no x-intercept. No x-intercept. So the y-intercept is 0, negative 2, and there's no x-intercept. Now, as far as asymptotes are concerned, there's no horizontal asymptote, and I'll tell you why. The reason is because since the degree of the top is bigger than the degree of the bottom, this is a higher degree polynomial, and this is a lower degree polynomial. So therefore there's no horizontal asymptote. As far as the vertical asymptote, that's simple. That's just x equals 2. If I make the bottom equal to 0, because x equals 2 makes the bottom equal to 0, but the top will not equal 0. So that means there's a vertical asymptote at x equals 2. In other words, if I would plug in 0, I would get 0 minus 0 plus 4 over I'm sorry, not plug in 0, plug in 2. Sorry about that. I plug in x equals the vertical asymptote equals 2, or it's actually the line x equals 2. And again, the reason is because if I would plug in 2, you get 2 squared minus 2 times 2 plus 4 over 2 minus 2, which becomes 4 over 0. So basically, as x approaches 2, this is going to shoot off to infinity. So the vertical asymptote is 2. And there's no horizontal asymptote. So these are all good clues, all good things to realize when we graph this. But now we're going to get really down and dirty, and we're going to start doing some calculus. Remember, the first 3 steps are all algebra, and now we're going to get down and do some calculus. So we want to find step 4 is basically to figure out everything that the first derivative can tell us. Increasing, decreasing, all that kind of stuff. Max, mins, all that kind of stuff. So let's do that. So y prime, well, it's f prime g minus f g prime. So f prime is just 1. So you have, I'm sorry, f prime is 2x minus 2 times g, which is x minus 2, minus f, which is x squared minus 2x plus 4 times g prime, which is just 1, over g squared, x minus 2 squared. And let's just simplify this. This equals, let's see, that's 2x squared. 2x squared minus 2x, and then minus 4x, so it's minus 6x. Then plus 4. Minus 4 and minus 2, right? And minus x squared plus 2x, then plus 4. Let's get that all together. That becomes 1x over, and it's all over x minus 2 squared. And that's going to, and y prime is going to simplify. Let's say it's going to be x squared, and then minus 6x and plus 2x is minus 4x. And then 4 4 is 8. And that's going to be over x minus 2 squared. Before I go on, remember I told you I would let you know if I made a little mistake. I say I did make a mistake because there's a minus 4, so that should be a negative 4. And then I have plus 4 minus 4, so that's just that's gone. That's just so it's x squared minus 4x over x minus 2 squared, and that's y prime. Now, when does y prime equal 0? So I have to, y prime equals 0 if the top equals 0. So I'm going to set x squared minus 4x equal to 0. And that's x times x minus 4 equals 0. So so therefore it is so yeah, it's critical. The critical numbers are going to be 0 and 4. So if x equals 0 and x equals 4. Now we also mentioned it being undefined, that if y prime is undefined, that would also be a critical number. The thing is, the number that makes y prime undefined is 2, x equals 2, because if the bottom of the fraction is 0, I get x, then that's undefined. That would mean x equals 2. The thing is that 2 is not, if you remember, 2 is not part of the domain of this function. So therefore it doesn't count. It's not a critical number. So the only critical numbers are 0 and 4. Okay, let's move up a little bit. So let's draw our little thingy here. So basically we have our number line for y prime, and that's 0 and that's 4. And we're gonna let's let 5 be a critical number. And let's let, I don't know, 0, 4. Let's let 3 be a critical number. I think that'll be nice. Yeah, 3 would be a good one. And let's, we'll let, I don't know, negative 1. What's a good one? Yeah, it's a negative 1. Can't think of a better one. Okay, so we're going to plug into y prime. -1, squared minus 4 times -1 over -1 minus 2 squared. And that's equal to, oops, let me, and that's equal to 1 plus 4 over 9, which is positive. So this function is positive here, which means it's positive means increasing. It's increasing in this interval. And now we're going to plug in x equals 3. So this becomes 3 squared minus 4 times 3 over 3 minus 2 squared. And that's 9 minus 12 over 1, which is negative, which of course means it's decreasing in this interval. And we'll plug in x equals 5. So we get 25, 5 squared minus 4 times 5 over 5 minus 2 squared. And this is 25 minus 20 over 9, and that is positive. So it's increasing. Well, we see here that we have if it's increasing and then decreasing, that means that this is a max. And if it's decreasing and then increasing, goes from negative to positive, then this is a min. So we have a max at x equals 0, a min at x equals 4. It's increasing. So it looks like it's increasing, then it's decreasing. And looks pretty good here. Now, I like to, every so often, I like to just stop along the way and just take a quick sketch of what I have. So I have the y-intercept we said was -2, which, by the way, -2 happens. What? That's an interesting thing. The y-intercept is actually 0, -2, and 0 is also a max. So the y-intercept is going to be a max. So it's going to, and now the vertical, we said there was a vertical asymptote, and x equals 2. Looks like it's going to come up here, max at 0, 2, and then go down like that. And then on the other hand, it's going to descend until we're going to have a min when x equals 4. What is when x equals 4 again? I don't know how far down it's going. We'll see when we put it all together in the end. Actually, you know what? I could do that right now. Let's find the. But again, I just want a rough sketch right now. I'll put in all the gory details later. So it's going to come down the asymptote, and it's going to min out when x equals 4. Now I don't know. I'm not saying. Now I know it's not going to go lower than the x-axis because this thing has no x-intercept. So somewhere up here, it's going to mess out. Again, this is a very rough sketch. But I just wanted to kind of put together what we have so far. We have the vertical asymptote when x equals 2. We have it's increasing here. It maxes out at 0, -2, and then it goes down to the vertical asymptote. Notice it's decreasing, and here, even though it jumps up on the other side of 2, but it's still decreasing this whole way down. That's decreasing and that's decreasing. So it's all decreasing in this whole interval. And then it starts increasing after it hits the max at 4, something. We'll get that comma something later. And then we'll use that. That'll be our range. So I'm pretty this looks pretty good. This looks like a pretty nice rough sketch. But let's get the second derivative and see whatever else we could wrangle out of this. Points of inflection and like that, and then we'll fill in all the values, and we'll be as right as rain. So let's just go and switch papers. We need a new sheet of paper now. Okay, everybody. Now let's do step 5, which is taking the second derivative and seeing what we can learn from that. So step 5. So y prime. Well, again, the first derivative was a fraction, so it's going to be f prime g. Now, f prime is going to be 2x minus 4. times g, which is x minus 2 squared, minus fg prime. So f is x squared minus 4x times g prime, which is 2 times x minus 1. And that's going to be over g squared, which is now going to be x minus 2 to the 4th power. So we got so let's work this thing out step by step by step. So y prime equals okay, but this term had I had written x minus 1, but I corrected it to x minus 2. That's what it's supposed to be. Anyway, notice I have an x minus 2 here and an x minus 2 there. So I'm going to make this a little bit easier by factoring out that x minus 2 from the numerator. So it's going to be x minus 2 times, let's see, 2x minus 4 times x minus 2, which is 2x squared. 2x minus 4 minus 4x minus another 4x, that's minus 8x, and then plus 8. And then minus, oh boy, minus 2x squared plus 8x. And if you know, let's see. So we have here, we have a and notice here we have a plus 2x squared, a minus 2x squared, a plus 8x, and a minus 8x. We just have an, and then anyway, this is all over x minus 2 to the 4th. So this now equals 8 times x minus 2 over x minus 2 to the 4th, and that just equals 8 over x minus 2 to the 3rd. Well, this never has, the top is 8, which is never equal to 0. And the bottom, so the top can never equal 0. The bottom can never equal 0 because x equals 2 is not part of our domain. So basically, y double prime has no, never equals, never is never, y double prime does not, never equals 0, and it's never undefined. So that means no possible points of inflection. No possible points of inflection. But we still have to check out concavity, and x equals 2 is still a dividing line as far as concavity is concerned because the function, it's not defined in the sense that it's not part of the domain. So I have to check out the concavity separately. So I'm going to look at y prime, y double prime, sorry, which is equal to x. Look at that before 2 and after 2. So I'm going to look at what x equals, let's say, actually, you know what's going to be easy? Yeah, it's actually going to be easier. That doesn't matter. I'll look at 0, which I always enjoy, and I'll look at 3, which I like. So when x equals 0, this is 8 over negative 2 to the 3rd, which is equal to negative 1, so it's negative. So it's going to be concave down. And when x is equal to 3, I get 8 over 3 minus 2 to the 3rd, which is just 8, which is positive, which of course is concave up. So there we go. Now there's a couple of things I wanted to do. I wanted to find the value at that max point, and I want to find the at the midpoint. I want to find the actual y values. I hadn't done that. So I want to just clean up a couple of things, take a couple of loose ends here. So I want to rewrite the original function. The original function was y equals x squared minus 2x plus 4 over x minus 2. And I want to look at the max I got and the min I got. So the max I got was at x equals 0, and the min was x equals 4. So I wanted to find y of 0, and I also want to find y of 4. let me just fix this thing right there. Okay. The y of 0 is going to be 0 minus 0 plus 4 over -2, which is equal to -2. So 0 comma -2 is the max, which actually we had that already. We'd figured that out because it happens also with the y-intercept. And y of 4 is the other critical number, and that which turned out to be a min. So if I have 4 squared minus 2 times 4 plus 8, plus 4, sorry, over 4 minus 2. So this is 16 minus 8 plus 4 over 2, which is 6, I think, right? 16 minus 8 is 8 plus 4 is 12 over 2, which is 6. So the min is 4 comma 6 is our min. That means that the range of the function is going to go, if you remember what the rough drawing that we made, and I'm really not changing the rough drawing at all, hardly, because really nothing changes, because I just get that this is concave down. That's which is pretty obvious. That's concave up. It's pretty obvious. The only thing I want to add in is that that's 6, and that's well, that's -2. So the range, which I had left out, the range is going to be -infinity, comma -2 union 6, comma infinity. And that's the only part I had left out. So now I have my range, and see, it's right there, range. Found the range. That's basically a range finder. Anyway, and that's it. Let's graph this on Desmos to get a nice big picture of it. And there's nothing else. There's no points of inflection. We're basically good to go. We got it all. Let's see if Desmos matches our rough sketch. Let me just go to Desmos right here. Okay, so I'm sharing my screen, and I'm going to type our function into Desmos. Y equals, let's see, it was x squared minus 2x plus 4, x squared minus 2x plus 4, and that was over x minus 2, x minus 2, and let me get this out of the way a little bit. Let me move, let's shrink it, drop. And there we go. There's our min is at 4 comma 6. Our max is 0 comma -2. I'm going to draw a line here. I'm going to draw a line here, a dotted line of the asymptote of x equals 2. So we're going to go draw x equals 2, but I'm going to make it a dotted line. And there we go. And that's our vertical asymptote. There was no horizontal asymptote. This function actually has what's called a slant asymptote, or an oblique asymptote is another way of saying it. Let me just type it in. X equals y, and make that. If you notice here, I'm going to explain how I got this. Let me just. If you notice this green line here is the line x equals y, and the curve is asymptotic. So on this side is a vertical asymptote of x equals 2. This side over here, what I'm doing now is kind of a bonus. It's kind of a bonus extra bonus asymptote. This is called oblique asymptote, and it happens to be the line x equals y. And I'll show you again. This is kind of like bonus round, and I'm going to just show you how I got this from. So let me go back to the other screen. It's very simple. Let me just go back to the other screen, and let me just go Oh, this whole time, you know something? I was just showing you all this stuff. I'm sorry, everybody. I forgot to switch cameras. So, okay, this is what I was showing you on Desmos. So this is our graph. The red curve is our graph. X squared minus 2x plus 4 over x minus 2. That's the red curve. X equals 2. That's the vertical asymptote. There is no horizontal asymptote, but there is a oblique asymptote. Some people call it a slant asymptote or oblique asymptote. It happens to be the line x equals y, and I'll show you. I'll show you where I got this. So y equals x is probably the way you usually write it. But let me show you how I got this. So let me now go back here and switch cameras the way I'm supposed to. And there you go. So the original function, and again, this is something you may have learned in algebra, you may not have learned in algebra, but I'll show you now. It's a very quick thing. It'll take a longer to. Okay. So again, let's just look at the original function. The original function was y equals x squared minus 2x plus 4 over x minus 2. Now, if I do if I actually do the polynomial division, since the bottom is just x minus 2, I'll do a synthetic division. So I get 2 into 1, negative 2, 4. And bring down the 1, that's 1. 2 times 1 is 2. Add them up, I get 0. 2 times 0 is 0. Add them up, I get 4. So that means that this is equal to x plus 4 over x minus 2. So in other words, y equals x plus 4 over x minus 2. And that's another, this is just another way of writing the original curve. This is the original curve, which you know, the round, it's actually hyperbola. This is the hyperbola. But if I look at the limit as x goes to infinity of this whole thing, if I look at the limit as x goes to infinity, this just becomes y equals x plus 0. In other words, it becomes y equals x. So this this hyperbola is asymptotic to the line y equals x. There is such a thing as oblique asymptote or slant asymptote. And I may as well. We're all very educated, and you all learned a lot. So let's see. I think I'm going to. There's one more I wanted to do, but I'm just going to make it a separate separate video. I'm going to make a. I think I'm going to make a bunch of, because these problems can get long, so I'm going to make a separate video. Okay, everybody. See you next time. Bye.